Right now, what we are doing is we are going to go through. You are doing your do now, go through your do now. So in our do now, you're looking at these two different graphs. We've been talking about this idea of adaptive traits, natural selection, and you're looking at our newt population that we've been discussing and talking about. So thinking about what trends, what changes do you see? You're looking at the first generation. Remember the first generation? This right here is our first generation. And over here you see your current or today's generation. So right now you're thinking about those two questions and you're checking off which box do you agree, which provides the most evidence. And then the question at the bottom says, how has the rough-skinned newt population changed? So based on our data, based on our information, you should see some very, very distinct changes. Right now, as you are finishing up, take about the next 4 minutes, and then we shall begin class for today. Once again, take about the next 4 minutes, and then we shall begin class. I'll take attendance right now. And 7, once you're done, you can go to the bathroom. You do now? Desire is absent. Gotcha. And missing that. Once again, right now, about 3 minutes remaining. You're reading that prompt. Once again, there are 3 questions. The first one, which description matches the histogram of population 50 years ago? And then the second one, which description matches the histogram of the population today? And then the third question, how has the rough-skinned newt population changed? About 2 minutes, and then we'll discuss. Remember, this will be our lesson 1.5. Tomorrow's 1.6. So we're looking at an assessment most likely Monday. You know, I hate assessments on Mondays. So definitely expect to see one by Tuesday. And it's all on chapter 1, all on natural selection. So make sure you're making note cards for your definitions and reviewing your work. And remember, there is a link on Google Classroom and you can practice and redo all of your lessons from that section. Got about 1:30 before we begin. If you are done, just give me a thumbs up so I'm not wasting time. If you are done, give me a thumbs up. All right, we got about 1 or 2 still working. 1 or 2 still working. All right, take about another 30 seconds and then we will finish this up. Once again, remember, you're comparing your 2 graphs. Specifically, we're talking about this idea of adaptive traits. Adaptive traits. Put the finishing touches onto your work. All right, I'm going to, just for the sake of time, because it looks like most people are finishing up, I'm going to stop my timer. All right, so looking at now our do now, right? Well, clearly our data is telling us some specific things, right? Really quick, let's look at question, well, before we get there, let's look at our data right here. we know that when we see poison levels, what did that one represent in our poison level right here? What did that one represent? Ricks, you said, say that one more time. Low poison, right? The one represented low poison. What about this 10 though? What about this 10 right here? Lighting? High poison. Now you clearly see some numbers here, and then you clearly see now 50 generations later what kind of changes occur. So somebody help me out. In question number 1, what was the best or what made the best possible sense for an answer for question number 1? I'll start with Kanye. Kanye, you take 1. Marie, you take 2. And then can I get a volunteer for 3? Sure, Sky, you can take 3. Go ahead, Kanye. Number 1 says, which description matches the histogram of the population 50 years ago? So our beginning population. You said the first answer. So most of the newts had low poison, and there are very few with high poison. How many people agree with that claim? Got 1, 2, 3. Good. Pretty much the majority of class. Let's go to the second question then. Marie got the second one. Which description matches the histogram of the population now today? Right? Most of the newts, I agree. I'm sorry. Anybody else agree with that statement too? She picked statement number 2. Number 2. Anybody pick anything different? It's okay to go against the grain. All right. Absolutely. Number 2. It says that most of the newts had high poison levels, where very few had low levels. So then the bottom question, Sutton, wrap us up with that one, Sky. Absolutely. Did anybody remember what kind of caused that? Was that something that the newts decided that they were like, you know what, I'm tired of getting picked on. I'm going to go in my corner, I'm going to meditate, do some yoga, and come back and be super poisonous in like a few years? Or what occurred to cause them or their populations later on, 50 years later, to have high levels of poison? Was it them or something in their environment? What was it, Rico? Environment. Anybody remember, recall, kind of give me an idea. What do you think occurred? No? We still gathering evidence? What do you think, Scott, before we go in? Who? You say predators. I like that. So for today, go ahead, open up, and let's turn to page now 27 so we can see what we're getting into. What we want to talk about is think about this exact same idea, right? Now, we're talking about the rough-skinned newts, but not only can rough-skinned newts show variation. And by the way, when we talk about variation, I want to go back real quick. Somebody help me out. What was an adaptive trait again? We said an adaptive trait is what? And if you don't have this definition, copy it right now into your notes. What's an adaptive trait? A trait that's going to help an organism survive. And this is the part I want you to add to it. Not just survive, but pass it on to their offspring, right? And what did we say offspring was? Their kids, their children, so on and so forth, their next generations. So remember, if you don't have that, an adaptive trait is going to be a trait that is favorable and is going to help that organism survive. Well, then the opposite. What's a non-adaptive trait then? Non-adaptive. Knox. Right, a trait that's less likely to help an individual survive. And we know with our newts, the trait was higher levels of poison. So now here we have a little kind of example. Really quick, before I even get there, somebody help me save my soul. In my first class, no one had any idea. My second and third class, they did. Before I even get this, I'm going to write this on the board. This right here, this photo, and these are actually 2 real photos. This is pre or before the Industrial Revolution. Hold on. And this right here is going to be after your Industrial Revolution. Somebody save my soul right now. Somebody tell me, what was the Industrial Revolution, or what was it centered around? What was the Industrial Revolution, or what was it centered around? Kanye, start us off, and then we'll go to the lighties next. Not so much. Not so much. When we talk about this idea of the Industrial Revolution, what are you saying? The increase of products being made, I like. We're getting there. Absolutely. Now, think about why that matters, right? We're going to move from, and this is now, we're talking about before the boom of factories. This industrial revolution is going to be the boom of factories. And like Amin just said, things were made by hand before, right? Yeah, we can get things made, good quality, things like that. But now we're able to make things in machines. We can mass produce them, right? Make a bunch of them. But what would be a downside of having factories and then factories popping up all over the place now? What's the downside of factories? Carl? Animals' habitats can be ruined. That's happened in the past. Anything else? Anything else? What do you think, Scott? Chemicals being put in the air. Anybody else? What are you thinking before we get into this? What other things could try to maybe, or factory could be a negative side effect? The chemicals in the air can actually affect their environment. So let's look at these two photos. Before our industrial revolution and then after. Well, right here we had this population of what we call the peppered moths. So in our pepper moth population, we had white pepper moths and then we also had black pepper moths. Now let's go back. Let's think about the earlier generations. By the way, these white speckled trees, right? What do you think if, by the way, let's say I'm a predator, a bird. I'm getting my flying on right now. Which of these, if this was the environment, you got your white pepper moth or your black pepper moth. If I'm a bird, I'm easily able to spot and be like, lunch. What do you think? Take a few seconds, turn and talk to each other. Take 30 seconds. Which of these moths, if this was my environment with pre or before the factories, which of these organisms would be able to easily blend in and probably survive faster or survive longer? Take 30 seconds, turn and talk, go. I like some of these conversations. Keep going. In the first picture, which of them are easily able to be spotted? All right, I'll go. Let me try that again. I'll go. All right, so looking at the board, right? Looking at what we have here. So I see this situation, Before my industrial revolution, you see clearly which of these organisms would be able to easily survive because of something or blend in with their environment.
I said I feel like it was a little bit of both because the black moth, if it goes inside the dark, the bird won't really see it, but the white moth stay on that tree, it will be a lot more of the white moth.
I like that thought, but now here's the question. In the beginning, before the Industrial Revolution, do we have a lot of black colored or covered trees? No? So what's going to happen to the black moth population around this generational time? What's going to happen? Elijah? It's going to get killed off, or it's definitely going to be really what? Small or low. But now, these factories are popping up, specifically in England, right? They're all over the place. And these trees now are going to change. Why? Because we know factories produce pollution. In this case, during this time, we didn't have the technology or the resource that we now know to understand pollution and how it changes our environment. So these factories would produce huge amounts of black soot, right? Like if you look at a chimney, that's what's created when they burn those logs. Inside that chimney is these black, thick, like goo type of thing. So this is now what's going to coat our trees. Now, if I'm a predator and I'm looking for my food, which of these are easily able to, one, blend in, and the second one be spotted then? Which one? I mean, it's clear, right? Rico, which one can I, if I'm a predator, can I easily identify right now with my change in environment? The white ones, right? What do you think now is going to be the change in population? What do you think is going to be the change in population? No. Which one? The white population, do you think it is or you know it is? Think about what's going on here. What do you think is going to happen? Give me some definites. Go ahead.
The white population is going to decrease, while the black population is going to increase.
White population is going to decrease while black population is going to increase. Anybody else agree with that? I absolutely do. Let's take it a little bit further for today. We just talked about how camouflage is absolutely going to help in this situation to be favorable. And also, by the way, was the change in their population due to them? Like the black pepper moth was like, I'm tired of dying off. I'm going to morph into white. Woke up, I'm white. No? What occurred to cause something favorable? Okay? The environment was changed. Good, good, good. So we're going to keep that idea about our environment. What we want to do is we're going to investigate whether blending in with your environment is always, remember this word, always helpful. Is blending in with your environment always helpful? What are you thinking? You say yes? All right, I like these thoughts. Let's find out. So the idea we want to think about is we're going to observe yellow, green, and blue australos. You know, our fake bird. So the question we want to think about, if blending in with the environment always or is always adaptive. And by the way, what did adaptive mean again? What did adaptive mean again? Adaptive? A trait that's going to help something survive. Is having an adaptive trait always going to be good in this case? Follow along with Corbie. Right now, though, on page 27, I want you to take a stance. Our question says yellow. Is the color yellow, and remember an adaptive trait, is yellow color always an adaptive trait if we are in a yellow environment? We're going to look at two sims, and then going to try to think about it. Right now, though, I want you to take a stance. What you believe? Do you believe yes? If I have yellow color and I'm in a yellow environment, then that's going to be adaptive because it's going to help me survive. If you believe that, circle I agree. If you say, I don't know, Corb, I don't know. It might not be that. If I'm yellow in a yellow environment, it doesn't mean that I'm always going to survive. If you believe that, circle I disagree. And what we're going to do is actually put that to the test. So can I get somebody to read for me the first three bulleted points on where it says you're going to do? First of all, our goal is that we want to gather some evidence to support or refute this claim. And the claim is right here. Is yellow always adaptive if I'm in a yellow environment? Can somebody read for me the first three bulleted points? First three. Marie, go ahead. Good. So first things first, I'm going to open up my sim. I just heard some things. It just kicked me out. So give me 1 second. Let me log back in. Now, really quick, I heard two very spicy words. I heard abiotic and then I heard biotic. What's so spicy about these two words? Why should we know abiotic versus biotic? Why? Somebody I did not hear from today so far. Did not. Don't look around. I see your head turning. Somebody. Cook, tell me, what's abiotic mean? Right there. Make sure you jot it down. Make a note card from it. Saunders. Non-living. So, once again, you see non-living. What's biotic then? What's biotic? Biotic done? Living things. So, they just told me I'm going to change some things. Let's do this right now. You should have made a prediction. So the first thing I need to do, I'm going to just zoom in. Excuse me. I'm going to zoom in so I can see my environment. By the way, I'm going to change this to my camouflage sim. Are we good so far? Now you see the color of the background, a specific color, but it told us what should we change it to? Yellow what number specifically? Yellow 7. So first thing I want to do, abiotic means it non-living. Yellow 7. Are we good so far? The next thing I want to do is these carnithons, and I'm going to zoom in so you can see them. These carnithons are the predators for our australos. But here's my question with the predators. Looking around at the beginning populations, what colors, and I'm going to roll around, what colors do you see of your australos? Hold on. What colors do you see? If you see a color, give me a hand raise so we can identify it. Anybody see any colors of your australos? Marie, give me a color you see. I see green as well. Anybody else? Anybody else? Anybody else? Rob, give me a color you see. You say red. Well, the red are going to be the predators or the carnithons. That's the predators to our ocelos. Seth? Blue. I see blue. I see green. Is there another? Is there another? Scott? Yellow. Now, here's my question. Remember we just said this. And I don't know what you picked. You will tell me. But does having a yellow color always adaptive in a yellow background? Well, let's run this right now. And what I want you to do is I want you to think about this question as we go through. Which ostelophs were more likely to survive and which became more common, while which were less likely to survive? I'm going to run it and we're going to hit this sim, going to speed it up. We want to get to generation 50. I'm going to move it around a bit and tell me if you observe anything particular while we're going around. I'm just going to leave it in one area. See if you see anything particular happen to our population. Think about what's occurring. Think about what we're talking about. I'm going to move it around. I'm going to move it. Anybody noticing anything? We're at generation 18. Anybody notice anything about your populations? Anybody notice anything about your populations? Sutton. And then Anaya? You said they're going after the blue ones first. Well, no, that's definite. But I see where you're trying to go. I see where you're trying to go. Anaya? They're going past the yellow ones? Anything else we might notice, Marie? The yellow population is increasing and the other populations are not. I'm going to pause it in a bit. We are at generation 47. We want to go up to 50 to see what we have. I'm going to pause it right here. I'm going to just scroll around. Remember what we saw at the beginning of our sim to what we have now. Anybody notice anything? Well, let's click analyze and see what we have. When we look, our striped line is the original population. What do you say about the distribution of traits? Is it kind of even? Is it spread out? Or is one taken over in the beginning? In the beginning. What do you say? It's pretty spread out. It's pretty equal, except here might be way less yellow. But now, 50 generations later, how has it changed? 50 generations later, do we... Oh, I'm sorry. Right here, Kaya, what do we have?
The yellow ostrich fruit increases and the other one decreases.
The yellow increase, the other decrease. By the way, how is there any other color? There's no other color. I want us to think about why. What were the yellow ones able to do? What were they able to do, Tyler? They were able to blend in with their environment, which gave them a higher chance of survival. So absolutely, in this case, the yellow color is adaptive if I have a yellow background. Does that make sense? Right now, if you have not, I want you to go ahead and answer that question on page 27. Which ocelots were more likely to survive? Which were not? And if once you're done that, I want you to go over to page 28. 28 is going to be important. Right now, you're going to use the next minute and a half, and I want you to answer or finish answering that question at the bottom. Which of these ocelots were more likely to survive, and which were less likely to survive? And then we'll go into our second part. If you are finished that question, go over to page 28. And now it's asking you, does our evidence support or does it refute our claim? Does our evidence support or refute our claim? We'll discuss in a bit. Having this yellow color in a yellow background, is that adaptive? And then we want to run this again. but I'll show you how we'll tweak it just a bit. All right. If you have this or you have that question 20, actually, I'm sorry, use some time, go over to question 28. Remember 28? Now, 28 says, once again, does your evidence support or refute your claim on page 27? And explain what happened to the populations in those environments. What supports or refutes the claim that yellow is always an adaptive trait? Rico, you had a thought? You want to share your thought while some scholars are still gathering their ideas? Go ahead.
Our evidence support our claim because we can clearly see that the yellow population increased while the blue and the green population went extinct.
God, you said our evidence clearly supports. Anybody else? I like that thought process because you connected it back to the why. Anybody else? Anybody else? When we talk about our yellow adaptive trait. Anybody else? Anybody else? All right, make sure you answer that. All right, right now what I want you to do is we're going to finish up this last part and then we're going to discuss or report out all of this. Now, here's the difference. We're going to switch this up. Let's go back to the exact same build, but we're going to change it up a bit. In this case, we're going to run our camouflage sim again. We want to change our surface color back to yellow 7. Now, we just saw it. We just saw yellow 7 and what was possible if we had our predators. But in this time around, we want to get rid of predators. We want to see, does that have an effect? So we just got, and I'm going to show you, we just got rid of all of our predators. In this case, we just have now our australopes and our thorn palm population, our bird and our tree population. Now, we're going to run this exact same experiment. And by the way, at the beginning, our distribution is pretty much equal, right? We got maybe a little bit less yellow, but we definitely have blue. We definitely have greens as well. Let's run this with no predators. I'm going to fast forward it to 4 times, and then we're looking for generation 50. I want you to see if you notice anything. I'll move our item around. Do you notice anything about your environment or your population? That's what we really want to look at. Anybody noticing anything? Nobody? Give us some more time. We are at generation 20 now. We're going up to generation 50. We're at 29. Anybody notice anything about my yellow population? Because that was the main character just now in our last sim. Anybody notice anything about yellow right now? What happened? You said the yellow's increasing. Okay, that's one thought. Anybody else with a different idea? I heard somebody whisper down the lane over there. And now we are 46. We got about 3 more generations. And then we're going to analyze this. About 3 more generations. And then we're going to analyze. So right now, I'm going to click on my analyze. What does our data show us? Well, we know that our original population is going to be in our stripe. In our stripe line color. Whereas, our 50th generation now is going to be our blue line. What do you see occurring with your generations? First of all, you see in our first generation is pretty spread out or evenly distributed, except maybe for yellow at the end, right? Now, here's my question. What do you see change? How has this changed? Take 30 seconds. I want you to turn and talk to each other. How has the original population changed to my 50th generation? Turn and talk and go. I like those conversations I'm hearing from the ladies. Keep going. What has changed?
Oh, like we're full of
What has changed? And now, really quick, let me plant this bug into your head. Let me plant this bug. Remember, we had a large population of yellow. And think about why. Now, look at your numbers and then try to wrap your head around that. First of all, what's happening with my population? Let's start there. Let's start. What's happening with my population? Vic? You said the blue ones increase. I would agree. Anything else? Anything else, Scott? The green increased. Anything else? Anything else? The yellow ones increased. Really quick, what do we notice about the original population of yellow anyway? What do we notice about them? Well, kinda. The original population? Say it every time. They died off? Well, if I look, was my number of yellows high in the first place? No, remember, think about that. It was not high in the first place. When we look, there's pretty much little to no yellow at the end. Matter of fact, there's none for 8, 9, and 10s. There's more here. In other words, when we look, there was more mixing of these colors, if you will, right? There's less of a predator to get rid of our yellow. Right now, looking at our packet, I want you to look at your packet, if you have not, on page 28. At the bottom, says which ocelots were more likely to survive. And this is what your second sim now. Which were more likely to survive and become more common. You see your numbers right there on the board. And the second, which ocelots were less likely to survive and become less common. Right now, I want you to take the next 2 minutes. I want you to finish answering that question. And then we're going to go on to page 28. I'm sorry, that is 28. 29. Go on to page 29. 29 is on the back after you finish answering. Remember, the question we're answering is yellow always an adaptive trait? And by the way, somebody remind Corbie, what's an adaptive trait? What is an adaptive trait? What is an adaptive trait, Marie? A trait that's likely to help me survive. Now remember your claim. The claim we said is yellow always an adaptive trait if my background is yellow. Somebody help me out. I mean, what are you thinking? Listen again. You see your numbers from the first, you see your numbers from the second. Is yellow always an adaptive trait if my background is a certain color? Or if my background is yellow itself? Is it always an adaptive trait? No, it doesn't always have to be. Why? Why do you say that? I'm just asking. You could be right or wrong.
Because in this one, it's less. Last time it was predator.
In this one, there's way less ocelots of yellow, and there's no predator, right? Well, when we think about that, the presence of a predator, by the way, is that an environmental factor, or is that something that the ocelots are changing? That's an environmental factor, right? When we saw when there was a predator, what occurred with the ones that could not blend in? They died off. Now think about the ones where there's no predator and what's happening to yellow. By the way, look at our numbers. Right now I want you to answer that question and we'll report out in a bit. If you are done, go to page 29. And then your same question. Does our evidence support or refute that claim? Does it support the claim that yes, yellow is always adaptive, or does it refute the claim? Once again, does it support or refute? Any thoughts while scholars are writing? You might spark an idea in somebody else's head. Any thoughts? Is yellow always adaptive? What do you mean? You said no. I heard no. I heard a few mumbles. Carly, what are you thinking? Right, and the second one, the yellow ones weren't the ones most likely to survive. Remember what adaptive trait means. Somebody, again, you should have this tattooed in your forehead by now. What's an adaptive trait? Kanye? Help you survive. Did the yellow trait for color and a yellow background help it to survive? Right? Make sure you put that in wording. Why that is not true. All right. Once you are done, give me a thumbs up. I'll give you, once again, you have about 2 minutes for page 29. 2 minutes for page 29. And it's simply what we just said. Once again, explain what happened to the populations in their environment And does our data support or refute that claim? If you are done, I want you to do this. You're going to take your page 30. That will be extra credit for today. Right now, what I'm going to do as you are finishing up page 29, I'm going to drop off your exit ticket. Make sure you read your questions and notate your question before you answer. And by the way, number 2 should say non-adaptive. I don't know why it came up. Once again, while you are finishing up, I'm going to drop off your exit ticket. So that means 2 things I'm collecting. Your completed packet up to page 29 and your exit ticket. What's up? No point being for the finish line. Stop. That exit ticket. Once again, once you are done, you are completing your exit ticket, and then you will drop it off. If you're done, I'll create 2 piles in the front, 1 for your exit ticket, 1 for your packet. Make sure that you remember we are finishing up 1.5 today, 1.6 tomorrow, and most likely your assessment by next week. Make sure you are making note cards if you haven't. So far we have the variation definition, generation definition, biotic versus abiotic, distribution, adaptive versus non-adaptive traits. I guarantee you will see all of those there. And in about 2 minutes, I'll explain what your extra credit is if you are interested. Take this time finishing up. Right now, you are on your exit ticket. Right now, you are on your exit ticket. Right. Yeah, so if page 30, this is how you're going to simply do it. Just simply, page 30 is going to be extra credit. And I'll explain what it is. You'll need the graph on the back in order to answer the question on page 30. But for today, I'm collecting up to page 29. And your exit ticket. If you are done, you can drop them off in your folders in the front. Yes. Yeah, right here. Bring it up front.
Wait, you said one of them is wrong, right?
Yes, number 2 for the exit ticket. Number 2 should say non-adaptive. Number 2 should say non-adaptive. Yeah, number 2 should say non-adaptive. I don't know why I came out. Thank you, Kanye, for catching that. Number 2 should say non-adaptive. Once again, right now, exit ticket. And then we will go through your extra credit very shortly. I'm actually going to switch this. Do we need this information to answer our questions still? Are we good? Can I change this? All right. And then we will take this note. It will be on our key concept section. So if you don't get a chance to get it down in the next 5 minutes, you will get it, or you can get it from the board. The major thing I want you to see for this is the extra credit work. And we've already taken the definition on prediction. But your extra credit, if you are doing your extra credit, you will need this graph on the back. Actually, let me erase this board. All right. So for your extra credit, you are looking at this graph and making a prediction of how it will look 50 generations later. But this is the information you need. At the bottom, it says that the environment is going or changing from high levels of rainfall. Once again, your graph on the back, your environment is changing from high levels of rainfall to low levels of rainfall. By population 2 should say low rainfall. So right now, or not right now, but for your extra credit, and that will be due by Monday, you will drop off this. You will finish or draw your predictions on the other side and answer your question on page 30. Are we clear on that? If you have any questions, you can definitely see me during office hours for clarity. Right now, though, you have approximately 3 minutes before your exit tickets are due and packets.